Hello, everyone, and welcome to No Planet B, a podcast where we're talking about climate change and its effects on Planet A. I'm Wyatt Jordan, and for this intro, Brianna is not with us, so I'm flying solo. But this week we spoke to Hannah Hess, who's a senior manager of the Rhodium Group, which is a part of the Climate Impact Lab, which is a group of climate scientists, economists, data engineers, and analysts working to put a dollar value on the cost of climate change. So yeah, we're talking here about the economics of climate change and the process of figuring out exactly what that means. And it was really fun, and we hope y'all enjoy it. Here you go. So Hannah, how and why was the Climate Impact Lab formed?
So the Climate Impact Lab formed 5 years ago in 2015 as a collaboration that was led by 4 principal investigators with the goal of simulating with incredible detail how rising greenhouse gas emissions affect human welfare. Specifically, we're trying to provide evidence-based and localized estimates of the economic impacts of climate change. And this sort of research is pretty siloed in academia, with a pretty complete separation between the climate science community and the econ community. And that makes it really hard to get a holistic picture of how climate change could impact the economy. But our group brings together, we're a team of about 30 now, climate scientists, economists, and data engineers trying to think about how to design evidence-based policies to manage climate change.
How does this team of scientists, economists, data engineers, and analysts communicate?
So the first couple years of the project, honestly, was just getting the climate scientist and the economist to talk to each other. Just breaking down those academic silos and the language barriers between disciplines. Because it turns out economists, by and large, don't get that much training in the physics of Earth systems. And climate scientists do not spend much time thinking about revealed preferences or cost-benefit analysis. There's the core research of empirical impacts, and econ is conducted by a staff of full-time researchers who are based in Chicago. And those researchers are managed by a team of postdoctoral scholars. And they're responsible for handling a huge volume of coding and cataloging the latest academic literature on climate impacts. And the students who are part of this team, they get training on econometric methods. So that's how you apply statistics and mathematical models to forecast future trends from historical data. And then they also get training in large-scale computation. So they're developing like a fluency in climate science, a fluency in econ, and a fluency in programming language like Python.
What's the importance of this collaboration?
The big question.
We all need to think about how much we're going to invest in strategies to manage climate change. And we have to do that with the understanding that the resources we're using to cut greenhouse gas emissions are competing for other priorities. That could be public health, public education, better infrastructure, national defense. So as we think about efficient allocation of resources, how we're going to divvy up the budget, we have to think about how much climate really matters to the economy. The idea behind this collaboration is how you could take these increasingly complicated global climate models and pair them with econometric research that's taking advantage of really rich real-world data about historical relationships between temperature, precipitation, being the climate data, and then the types of economic activity that we care about. So things like crop yields or labor productivity. How you can really combine these two things and then come up with a much more granular and a much more evidence-based estimate of the economic costs of climate change. So then the big question is, why is that important? There are 2 reasons. One is we can provide this evidence-based estimate to make a better social cost of carbon, which is a tool that policymakers use to weigh the benefits of policies that reduce emissions, or could be used for setting a price on carbon. And the second reason it's important is to give local planners, mayors, governors, and other decision makers who are trying to figure out what they need to do to make their communities more resilient to climate change, the actual information about what they can expect where they live, what climate change will mean for things like damage from a hurricane or future flooding of their farm or their energy bills. And fortunately for us, it is the same research process that can meet both of their needs. So that's what we're trying to do, is come up with a really evidence-based, high-resolution, local projection of the impact of climate change that people can use in planning, and at the same time fold together all of those estimates into an economy-wide social cost of carbon that can be used in policymaking.
So there's a term that you used that I'm not actually that familiar with, and it's social cost of carbon. Is there any chance you'd want to go into exactly what that means?
Sure. The social cost of carbon, Michael Greenstone loves to say that it is the most important number that you've never heard of. It tells you basically how expensive releasing an extra ton of carbon dioxide will be in terms of the damages that it will do today and the damages that it will do far into the future. As we know, the greenhouse gases hang out in the atmosphere, and it takes decades for the full effect of what we're doing now to be realized and borne out in physical impacts in the climate. The social cost of carbon kind of gives you a bright line on how much we should be willing to pay to get rid of that extra ton of carbon dioxide. Policymakers can use this to think about which regulations they could consider. So I'm just going to bring up two examples that a lot of people might have a guttural reaction to: this is the right or this is wrong. Talking about putting a ban in place on fracking, or talking about investing money to prop up nuclear plants across the United States as a source of carbon-free energy. So maybe you have a guttural reaction about which one we should be doing. The social cost of carbon, if you have an accurate read on how many emissions are going to be avoided with each of those policies, you can plug that in to the social cost of carbon, and it will spit out a dollar figure that tells you what the value is of avoiding that many tons of emissions. In being able to weigh different policies like that, it impacts which regulations we're considering, the set of alternatives that you're considering when you're designing a policy, how you rank those alternatives, and then what is the ultimate choice. So this could be used when an agency like EPA is thinking about different regulations, and it has been used under the Obama administration. There were 80 plus rules by EPA, DOE, and some other agencies that use the social cost of carbon to weigh the costs and benefits of regulation. And it's also useful for lawmakers on Capitol Hill. So there's an agency that scores the cost of new policies, and as part of that, you could imagine some big climate bill moving through Congress, they would need an accurate score of not only how much it was going to cost to enact this legislation, but what are the benefits that we're going to get, and how do you put a dollar figure next to those benefits?
In the lab, you have an analytical process. Could you talk about the three main things that you guys do in this process?
Sure. First, we have three kind of guiding principles that are really important to the way that we go about doing that work. And then I'll go into each one of the factors. So first, it's important to realize that there are a lot of what we would call confounding factors when you're studying how climate impacts the economy over the long term. So for instance, when you're looking at the deadly effects of heat waves in different communities, a place's level of income, the ability to have an air conditioner in their homes, in their schools, in their nursing homes, the quality of their healthcare system, all of that is going to make a big difference in outcomes. So we want to make sure we're not conflating any of those things with climate impacts. Next, we want to get really, really granular local data. So we divide the globe up into about 25,000 regions, the size of a US county or a Chinese province, so that we can drill down on any given hotspot and understand what's going on beneath the projection. So how are people actually responding? How are they changing their behavior to adapt over time? And how do we start to think about the costs of those adaptations? I'm going to bring it back to that air conditioning example while I'm sitting here talking to you in the Bay Area. How many days above 95 degrees in one summer is going to make my landlord decide, hey, I need to install air conditioning in this apartment building if I want to keep attracting new tenants and charging ridiculously high rent. Our third principle is that we know it's important to collect data that represents the entire global population. It's easy to find records and data from richer parts of the world.
Yeah.
It's more readily available, and the government has been collecting data like that for longer periods of time, or agencies have. But we know that we also need data from developing parts of the world because how they respond and adapt is going to look different. Climate change in Bangladesh is not going to be the same thing as climate change in Iowa. So those are our guiding principles as we go about this process. The 3 steps in our process are: 1, gather detailed global data. We are specifically studying how climate influences human health, agricultural production, energy demands, labor productivity, conflict, migration, and then coastal damage from sea level rise and storms. So in total, we have about 1.5 petabytes of data. If you're not a big geek, for some context, that's like a library of about 2 million high resolution photos. Specifically, it's death records. When it comes to labor, we have surveys about like how people are using their time. We have energy records from around the world. So next, what we're doing is assessing climate-driven economic changes. That means we take advantage of advances in cloud computing to comb through all of this historical weather data and the different outcome data to identify evidence-based relationships. And so that could be the relationship between temperature and corn yields, precipitation and violent crime rates, hurricane force winds and coastal damage. We take all those and we put them together to produce damage functions, or dose response functions, if you will. So that's what the public health community would call them. It's a mathematical equation that's saying for every dose of temperature or for every dose of precipitation, what kind of response would you expect to see in different parts of the economy? And then the next part of our process is mapping those dose response functions to climate projections from all of the leading global climate models that are being developed by research teams around the world. And we do this to help, again, coming back to our core mission, which is helping individual communities understand the impact of those changes in the climate that have already occurred, as well as what's projected going forward under a range of different emission scenarios. Step 3, that is trying to make this data actionable. We want to inform how people are making decisions and have an influence on policy and an influence on people's ability to adapt to these climate changes as they're happening. I can give you some examples of that if you'd like.
Oh, I'd love that.
Yes.
So our work has been used by the federal government here in the U.S. In 2018, the National Climate Assessment came out on the day after Thanksgiving. And it made a lot of headlines for the discussion in there of potential economic impacts. And that was based on our work. The House Budget Committee recently put out a report on the cost of climate inaction. So what's it going to cost the U.S. if we don't take any action? It was pointing to some testimony that Dr. Sal Shang gave about how you can see the climate as an actual financial asset to the U.S. So those stable weather conditions that have allowed us to have amazing agricultural yields or not have to spend too much money on heating or air conditioning throughout the year, those are an asset. And then what happens as the climate grows more and more unstable? We at the Climate Impact Lab were able to put a number on the percent of future GDP growth that's threatened by climate change. And that's kind of useful in thinking about the cost of inaction. Another example is our research on the link between conflict and climate change. We partnered with a group called the Skoll Global Threats Fund to prototype a platform that takes advantage of what we know about the relationship between things like drought and conflict or heat and conflict to help improve how humanitarian aid agencies and crisis prevention groups and national security agencies think about the risks, climate change as a risk multiplier or a threat multiplier. Yeah. You often hear that talked about when national security groups start to think about climate change. And we put together this prototype platform that integrates the lab's finding with seasonal climate forecasts to generate global maps that this humanitarian aid community can then look at to see which regions are potential hotspots for an increased risk of conflict due to near-term climate changes. Finally, one more recent example is in New Jersey. We released a report this past October on the 7th anniversary of Hurricane Sandy's landfall in the state, and that looked at how climate change since the 1980s has put a growing share of New Jersey's coastal communities at risk. In particular, we put a dollar figure on the impact of sea level rise and changes in hurricane activity, how fast hurricanes are moving, how much rain they're bringing, how much stronger the winds are over the past 4 decades, and also what that looks like for the years ahead. And we partnered with this design firm to make a really cool data visualization of our report. And then a few weeks ago, New Jersey took a first-in-the-nation move to try and manage this climate risk.
Very cool.
Yeah, so they now require builders to account for the impact of climate change, including rising sea levels, and also the emissions impact of their projects in order to win government approval for new construction. Yeah. And then
that's a big win.
It is huge. The governor's executive order cited our team's analysis of coastal risk in the text. In the text that was released along with that executive order. So that was exciting.
That's very exciting.
For sure.
That would be like a champagne popping moment, right? Like you see your name in there and you're like, oh yeah, cool. Here we go. Now, if only we could get that kind of thing to happen in Miami, Florida would be doing really, really well.
Maybe one day.
Now, so there's a paper that I wanted to ask you about. It is called Estimating Economic Damage from Climate Change in the United States. There were a lot of findings in it that I thought were interesting, and the one that I wanted to bring up first is that with global mean temperature increasing, there's roughly a 1.2% of gross domestic product cost per 1 degree Celsius increase on average.
That's a national level statistic, and it is big, it is important, it is adding up across those different sectors that we study. So looking at agriculture, looking at coastal damages, how death rates are going to be impacted by rising temperatures. When we add up all of those things, we get to that headline figure. But also what emerges is that the cost of climate change for the US depend entirely on what part of the US you're talking about. For instance, in Maine and the state of Washington, there's actually a net economic increase of about 2 to 3% of local income. But there's a net decline in local income of 23% or more in certain large counties. And that's especially true along the I-10 corridor, so the southern part of the United States. I think the most vulnerable county according to our research is located in Florida, and that's just primarily due to that importance of geographic positioning and what your starting temperature is. And also another interesting finding that emerges from that research is that some of the poorest parts of the US are the most vulnerable. That's the sort of information that gets averaged out if you're just looking at summary statistics. Climate change might totally sink the economy in the part of Illinois where I grew up. My family farms corn and soybeans, and as temperatures rise and precipitation is less and less predictable, you can see that part of the country is incredibly exposed. And in the way that the entire economy there depends on agriculture, just this gives you a really granular view of who is most at risk.
It discusses how the risk associated with climate change is going to be unequally distributed amongst the US, and like the trend that they found was that value was going to be technically increasing northward and westward.
Mm-hmm.
And so like the northwest is going to be actually increasing in value and the southeast is going to be decreasing. Solomon Sang, who is the public policy professor at UC Berkeley, said that like if we continue on our current path, the analysis indicates that it may result in the largest transfer of wealth from poor to the rich in the country's history.
Yeah, gets back to that really key takeaway for us, which is climate change. The impacts are going to look so much different depending upon how wealthy you are when you see these impacts, and also what your starting climate looks like. We kind of refer to that study as like the US prototype because our future research is all globally oriented. But you can think about how in poor places around the world, it's climate change is effectively just a wealth transfer. It's making some of the countries that are already better equipped in terms of a climate. It's making their agriculture do better. It's making their heating bills go down in cost. And then in places like the tropics, they're just increasingly destabilized by climate change. It's driving these coastal damages we talk about. It's wiping out crops. It's increasing the deadly effects of heat waves. And we see all of that in the data and again, can use it to draw a clear line in the sand for anybody trying to make climate change policy and show them, here's the impact of climate change on inequality. And if you want to do something about inequality, maybe one of the best areas of policy that you could address is climate change.
And I feel like people wouldn't normally think about that.
Yeah, that's why every time you say like how granular these studies are, or like the granularity of all these impacts, it makes me feel hopeful for some reason, for like hearing how in depth y'all are going with all this data. I don't know. I feel like climate change is such a complex issue that's really important.
Yeah, I'm happy to hear you say that.
You were talking about the how much hotter was your hometown like when you were born compared to now earlier. It assumes accordances with the Paris Agreement pledges, right?
Yes.
And in your line of work, how often do you assume that countries will stick to these pledges?
Rhodium Group, in addition to studying climate impacts as part of the lab, we also look at emissions estimates for the US. We look at emissions globally, and we do that to kind of say, how ambitious are countries being with what they're pledging to the Paris Agreement, for instance? How ambitious are US states being with their efforts to cut emissions? How dangerous is what's happening at the federal level in terms of reversing the progress that we've already made to cut emissions? And in December, our international team put out a study that found to keep warming below 2 degrees, the world needs to reduce emissions by a colossal 1/3 from current levels by 2030. From an international perspective, there are 5 crucial things that could get us globally on track to closing that gap. And those are the European Union adopting a Green New Deal, Brazil halting its destruction of the Amazon rainforest, China's economic growth and the emissions that it produces slowing down to a more sustainable rate, demand for electricity growing only moderately in India, and India choosing to meet that demand mainly with renewables. And then the 5th one is President Trump losing in 2020.
Wow.
Him losing would just affect the policies?
Yeah.
Moving forward.
Very not surprising, but for some reason I wasn't expecting that to be number 5. That makes a lot of sense, though.
We think it's really important to show the full range of possible outcomes. We don't want you to don't want anyone looking at these results to get too hung up on thinking about climate change impacts as like a forecast, as saying this, like we're looking into a crystal ball and here's what's going to happen in your future. Even if we could look into a crystal ball and somehow know exactly what's going to happen with the election in 2020 and how many coal plants are going to be built globally and how many EVs are going to be on the road, we still don't know exactly how the climate is going to respond to these concentrations of greenhouse gas emissions over the long term. And so that's why it's really important to look at the tail risks within a climate model. We have an approach that does that uses a method called pattern scaling, where we're taking the pattern of, sorry, I'm going to get really nerdy on you here for just a couple minutes. The pattern of global average temperature change that's projected in these big, comprehensive global climate models that are developed by research teams around the world, and then downscaling it to the local level to say, how does that impact the climate here for me in the Bay Area and the climate there for you guys in Florida? And so using this pattern scaling approach, we can get a sense of what the changes will look like in the future at the local level. And when you're talking about climate, you're talking about like a 20-year spread of the weather that we experience on a daily basis. We can look at the tail risks. So what does a really bad year look like within that? What is your 1 in 20 risk of a really bad year? And it's important to account for those tail risks, because that's where most of the damage occurs. That's where if I'm planning where I'm going to build my home or how I'm going to build my highway in Houston, it would be great to know that an event like Hurricane Harvey could happen and dump so much rain on you, and I would want to know whether or not I live in a floodplain that's vulnerable during an event like that. So taking into account these extreme events and these tail risks is really important. We would never want to, in other words, like model for someone, here is exactly what's going to happen. We always want to show them the full range of risks from a best case scenario to a worst case scenario, so that you can use that range to plan for the full spread of possible outcomes.
I was actually just curious about how y'all get your climate data. Do you use like models that already exist, or do you utilize models, or just like find data? How exactly does it work for someone who, like me, doesn't have experience with this stuff?
That's a great question. So to study potential climate change pathways and the impacts of different decisions about policy and different market developments, like, for instance, solar energy getting really cheap, climate scientists use these complex models known as general circulation models, or GCMs. These models encapsulate in computer code basically everything all of these large government teams know, government and university research teams know about the physics and the chemistry of how the Earth works. GCMs can be used to explore the full range of risks that we face along a possible pathway for greenhouse gas emissions growth. But as I was referring to earlier, how much we're going to emit in the future depends on a whole range of factors, like how fast the global economy grows, how much the population grows, the speed of technology development, and policy decisions. So it's hard to project those factors over the course of a decade, let alone over the rest of the century. And so the climate science community has come together and agreed about a collection of 4 pathways that represent plausible outcomes. Every leading climate modeling team runs these RCPs, these pathways, through their models as part of this process that's coordinated by the World Climate Research Program's Coupled Model Intercomparison Project. It's CMIP. Gotcha. Is the acronym that we use. And CMIP pulls together all these climate models and gives us a range of outcomes that represent all of these different pathways for emissions. The problem is that the information that we have from those global modeling teams is really only useful to people with a very sophisticated understanding of climate change. So you have to take all of that data from these global models and scale it down to the local level. That's what we are working with at the Climate Impact Lab, is the outcome of these big coupled model intercomparison projects. What we use right now is CMIP 5 that came out in 2014. And we're looking forward to, in 2021 is going to be the next round, CMIP 6. And there are going to be more of these pathways for future emissions growth included, including one that tracks a little bit closer to what the energy modeling community thinks we're on track for right now. as we continue to learn more about these things, we get a better understanding of again, just what kind of risks might be in store for us in the future and the full range of possible outcomes. Sorry, that was probably a much longer answer to your question than you ever wanted to listen to.
No, that was perfect. That was perfect.
Was great. Thank you.
That makes sense. That was something that I don't know, was just curious of as to like how the sausage is made when people say they find data for certain things.
Yeah, it's just a lot of computer code basically that is available through these big agencies, but like not really usable unless you know exactly how you need to transform it.
All right. Well, I think that's all the questions we have written down. We could do maybe like 2 of our listener questions. They're kind of goofy. They're never quite what you'd hope they'd be. But okay, so in regards to the cost of climate change, our listener Kevin says, how much it cost? And that's it. And that's the whole question.
I guess I would tell Kevin to stay tuned, because that's what we're crunching the numbers to try and figure out, and we're hoping to have a number that I could report out at the end of this year.
All right. Do you have anything that you would want to mention? Any groups you want to like advocate for? Any big takeaways you'd like to include at the end here?
Our website for the Climate Impact Lab is impactlab.org, and on there we have this really beautiful impacts map that allows you to play around with different scenarios for emissions and look at different temperature factors. So not only how many hot days are we going to experience, but how many fewer days below freezing are we going to experience. And we've actually used that to look at what the impact of climate change will be on sports. So
cool.
If you're looking at like more days above 95 degrees and what that means for impacts on physical exertion, how does that translate into people not being able to play their soccer games outside, or high school kids who play football having to have more and more of their games canceled or have like no more full pads practices? It's just one interesting dynamic to this whole one interesting dynamic that you can see when you're looking at a local level. And then on the flip side, when it comes to these declining days below 32 degrees, what does that mean for ski areas? Places like Tahoe out here in California, it already does not have that many days below 32. Days below 32 are important not only to how much snow your ski resort is going to get, but your ability to maintain artificial snow. And what does that mean for the ski industry going forward? What does that mean for people who love to ski? So just thinking about not only how these trends like play out in the economy, but what they mean for the activities that we care a lot about, and how society is going to have to respond to those changes. And we did a cool study looking at how your marathon finishing time is impacted by temperature changes, because it turns out that like the most record-setting marathons are run in temperatures right around where the average daily temperature is around 50 degrees. Mm-hmm. And if it's colder than that, you don't perform as well. And also if it's warmer than that, you don't perform as well. So we adjusted some record-breaking marathon times to the temperature to like be this ideal temperature. So saying like, okay, what if this person had run this race on this 60-degree day on a 50-degree day instead? And we found by looking at that, someone just broke that big record for like running a marathon in under 2 hours. And actually with like temperature adjusted marathon times, that already like had the climate conditions been perfect on the day those races were run, there were already a couple athletes who could have busted that 2-hour record. So it's just kind of neat to think about. That's the kind of thing that we can like sift through big amounts of data and apply these econ methods to figure out exactly how temperature is influencing people's behavior and sports performance and all that stuff.
That is really cool. That's on the Climate Impact Lab map, you said?
Yeah, you can look at all those temperature trends on the map, and then we have insights on our website that are that are more looking at these things. We did a partnership with Nike that looked at the climate change's impact on sports, and that's on Nike's website.
All right. Well, I think we're just about done. Thank you so much for being here.
Thank you for the invite.
Yeah, of course. This was very fun, very informative.
This was so awesome.
I'm glad. I hope I wasn't too wonky, and I really appreciate the time getting to talk to you guys. I think what you're doing is really important, just to help people understand this problem better and help people understand how it impacts their lives.
Thank you. It's I think everyone here is doing important work.
Thank you so much.
Hey everyone, thanks for listening. We hope you liked it, enjoyed it, listened to it all the way through, and learned a little bit about climate change and maybe a little bit about yourselves. Who knows? If you enjoyed it, you could do us the hugest favor in the world and give us a rating on iTunes or a 5-star review, or show it to a friend, because word of mouth is really the best way that we can spread the information and the knowledge and allow people to be part of the community. If you want to follow us on Instagram and Twitter, we are there at NoPlanetBcast. Our email, also, if you want to talk to us and send us any information, questions, whatever, our email is noplanetbfsu@gmail.com. So, yeah, hope y'all have a great rest of your car ride. Walk. I hope you have a great rest of your walk. And then, yeah, we'll see you on the internet.